doing exactly this sort of stuff. And this says not tested yet, probably buggy, which is true. Basically, the timing stuff here, I was doing a little thing here to sort of lock our frame rate where we waited. And we wait on the total frame time, which is a good idea. However, what I noticed is we don't track we don't snap that frame time. Basically this last counter thing, we don't snap this at the right place. What we want to do is immediately after we do sort of that lock, right at that time is actually when we want to get that end counter, because that is actually the thing that we are looking at for our total time. It'll still count, because you have to remember this is basically just a watermark that we insert somewhere in our loop. And if we're waiting for our target seconds per frame, we want to wait on the entire time that it takes to do everything up to this point. And then immediately after, we want to snap whatever that time was and count the rest of the stuff towards the next frame's time. Because otherwise, we'll wait till the target time. Then there'll be a bunch of time afterwards when we're doing stuff like doing our sync display and our buffer and all this sort of stuff. So this really needed to get moved to here, and we didn't do that. And we saw that. I remember I said we need to look at that tomorrow. We saw that in the fact that these numbers were wrong. They were a little over 33. And that amount that was over was exactly that time that was taken up in here, because we were waiting till our target frame time, which was 33, then still doing some work without count that would count inside that frame benchmark. So I just wanted to fix that to get one bug out of the way, because I thought of it last night after we finished. I was like, well, we've got one bug in there already. So I wanted to fix that and see, yeah, and so you can kind of see now as well, yeah, that's fine. Basically, you can kind of see now that 33 is right on the money. And that's what I wanted. I wanted us to be locked at 33 frames a second, and that's exactly what I wanted. Now this assert, we've got an assert here that fires anytime we miss our frame rate. And so that's, you know, what you would expect if you switch to another guy. So that this is kind of something that we're not going to be able to do anything about. Certainly, because when we do our sleep, the operating system, like I said before, when we do our sleep, if we're not the running application, we're not getting priority, we might sleep for a very long time. So this is just an assertion in debug mode to tell us when we miss our frame rate. So if we switch apps, it's going to happen, because Windows will just see no particular reason to give us the resources we need to always hit it. So that's fine. But now we are basically running at 33.33 milliseconds per frame exactly, as far as we can tell from our wall clock time, which is exactly what I wanted. So we know that that part's working properly. But when I look at our sound, you can kind of see there's some weird kind of gapping, unless we've got a bug in the way we're recording it. And you can kind of see what's happening there. If I pause like let's say I just take a pause here, right? I don't know if I can get, let's do it this way. I'm going to go ahead and take this guy sort of over here. So this way we can run the app. How well that will do this. So what I want to do is just stop it so you can see it. There we go. So what you can see is going on here is we're getting nice sort of equi-spaced samples most of the time, but then sometimes we get kind of these nasty hiccups where it's totally not right at all. You can kind of see that there were 2 lines in here, and there were 2 lines in here, 2 lines in here, no line there. So we're not getting a very stable read on the audio pointer, right? That when we're asking for where that is, it doesn't look like we're getting a very stable read from it. Now, I don't actually know at the moment why that is. It could be that this sound card just doesn't give us a very stable read back from the frame buffer. I honestly don't know. But what I can say is, at least right now, we're getting back a very unstable sort of piece of information from it for that play cursor. And I don't actually know exactly why that is. So it's something to think about, though. So what we want to do here is start to sort of improve our situation. What I want to do is kind of try to do something. Let's try to think about this here. I wonder if there's a way we can ask for slightly more accurate time, or if that's the most accurate time we're going to get. Because if you think about it, if that actually isn't buggy, right? If that is not buggy at all, excuse me, then we're kind of in a little bit of trouble to try and get audio sync. I mean, if you think about how inaccurate it would have to be if that's where it actually is. But so let's just take a look at that a little bit here, just to see if we can increase that accuracy, or if we're doing something stupid, or, you know, hopefully there's something we're just missing. So when we call this get current position here, let's just take a look at the documentation for that. Direct sound get current position, just to see if there's anything that we could be doing when we create the buffer or anything like that to make it be a little bit more accurate. I don't know if we can. or not. But let's see. Let us see what it says here. The right cursor in position which is safe to write, blah, blah, blah. We know all this. That is not going to help us. Let's take a look at the buffer creation stuff, just so we can kind of see. Set frequency is not really going to help. None of this looks particularly interesting, but we can take a look at some of these things like the caps and stuff, and then I can also take a look at this create sound buffer, so we can kind of take a look at whether there's anything we can do inside the buffer description to tell it that we kind of need some better stuff. So let's see. So we don't really know what position notify exactly is. I assume that was callbacks, but maybe that might have some bearing on it. Let's see here. Choose new place in direct sound. Let's take a look at what some of this stuff says, because some of this may be relevant. So, in direct sound, DirectX 1, the play cursor was significantly ahead of the actual playing sound on emulated sound cards. It was directly behind the right cursor. Now, of course, the application can get a more accurate play position. If this flag is not specified, the old behavior is preserved for compatibility. So, you know, I'm just, like I said, going out on a limb here. Let's just try some of these things and see if we can get that guy to be a little smoother and hope that it's just a little bit of something we're doing wrong that's causing that, and that it doesn't have anything to do with the actual platform, which would be a lot harder for us to work around. So I'm going to go ahead and set that in here. I believe it is, well, I guess it's only on our secondary buffer that we care. I'm not sure, if this flag is not specified, the old behavior should note that this flag affects only emulated sound cards with direct sound drivers present. Play cursor is accurate for direct sound in all versions. Well, this probably isn't an emulated sound card is the thing. So that's not a good sign for us. But what are you going to do? All right, we'll try it anyway just to see. Is there anything else on here that might have a bearing on it? Primary buffer, no. Static, no. Focus, no. No. Global focus, none of this stuff. None of this stuff looks particularly useful. Yeah. Well, we'll try. We'll try some things and see if we can get any luck. That definitely does not improve anything. Let me also double check that that's not the right cursor, that we don't have some kind of bug where we're asking for them in the wrong order or something stupid like that, because that could certainly happen. I just want to make sure. Let's see here. So back up a little bit. To get current position, it is the play cursor first, the right cursor second, so we're doing that correctly. Not much we can say about that. Set format. The set format is not going to have anything for us, I don't think. And get caps. Well, we can get caps bits, and there's not a lot there. We could see if it has this, but that's about it. So, I don't know, not looking great for our hero. What I will say is let's not despair just quite yet. You know, it's sort of disparage-y. It's sort of time to despair a little bit to get our despair on. But what I'm going to do is I'm going to do a Win32 time marker, or debug time marker. I'm going to go ahead and put something in here that's got basically a play cursor, and a right cursor, right, like that. And I am just going to go ahead and use that as what our array is. So our markers and our marker count. And then I will just sort of change this here to that. And so we can get Win32 debug time marker, this marker equals that. So at that point, I can do play cursor that way. And that will be easy for us to get out, and that's good. That should just be marker count. There we go. And then down in the other function here, we have to basically do debug time markers and debug time markers. Now you can see what I'm doing here is really very straightforward. I had something working where I was just recording one value and I wanted to record more than one value, so I just broke it into a struct. Again, this is that compression-oriented programming sort of style that I'm talking about, where just when you find you need something, just do the step that gives you what you need, and the code sort of marches towards better over time, right? It just gets a little cleaner, a little better, a little more flexible as you go, and everything hopefully works out for the best. So these are going to be our debug time markers, and that should be roughly it. So debug time marker index, debug time markers, and we want this to just be that. Probably could have done this with a search and replace, a lot easier, but you know, sometimes debug time markers, you just don't think about it. And this guy needs to be changed up here. There we go. All right. No conversion. You're right. There is no conversion. But you know what I can do? Win32 debug time marker. Marker equals address of that. So I can just snap the address of that. And then what I'll actually do is I'll just go ahead and get it directly into this thing. So there we go. Marker arrow play cursor, marker arrow right cursor, and now I've got both of them. So with both of them, I can now also go ahead and draw them both if I want to, and see how those look as well. So I'm going to go ahead and do that. I'll just lean on our vertical line draw again, and so basically what I'll do here is just say, okay, let's go ahead and pull that out as well into just a little guy that does this exact thing, that. And this will be Win32 draw sound buffer marker or something like this. And that will take, is substantively the exact same stuff, like so. It will just take the coefficient here that we had, and it will just do exactly this stuff. So this is where local functions would be really nice, by the way. You know, features that sort of get added to the language over time, stuff that you would want, that is definitely one of them. All right, so all we really need to do here is just pass this the things that it doesn't have, which is the C and the pad X, the top and the bottom. So I will go ahead and call that, and I'll call it on both things, like so. All right, so global back buffer, sound. I don't know why we're still calling this global back buffer, by the way. That's kind of absurd. It should just be back buffer in here because it doesn't actually care that it's using the global one. It's not global anymore. It's just using one that's passed in. So we'll get that out there, and we'll do this. So there we go, pad X, top and bottom, like so. There we go. All right, so that's all good. Now we just need to pass two different values to it, which is basically going to be this thing right here. So this is our value that we actually want to draw that's coming in, and I will just pass a different thing. I'll pass the play cursor and maybe the color here, and I'll pass the right cursor and a different color here, let's say, something like that. You know, and this might be a good time to turn off our gradient, to say the least. But, you know, it's so pretty. Sometimes it's hard to part with it, certainly. So we'll do that, and we'll get a color in here so we can do them two different colors. So I'm just going to pass the right cursor and the play cursor so I can see the two of them as well. So let's go ahead and fix that. Back buffer and back buffer. There we go. And that should be it. I should be seeing the red ones as well here. Yeah. It's just not looking good for our hero, is it? Yeah. Yeah. I don't know. That's not what you want to see, certainly, in your life. I mean, you can kind of see if I pause this guy at any particular point in the execution here, you can kind of see what's going on there. There's just a really, even though we've got some measure of verification that we're always updating ourselves at basically the right amount of time, we're definitely getting just a really bad kind of read back from the sound card here that sort of seems pretty unreliable to me. I don't know. Hopefully maybe we're still doing something wrong, but you can see why I'm just thinking getting any kind of tight audio sync when you've got that much variability is really just not probably something that's going to be on the table, if that makes sense. But what can you do? Of course, we're not really calling it right at the moment, so maybe let's go and actually do the work of what we're going to do today. What I was hoping would be enough today, but you know, with looking at how bad that is in terms of its stuff, it's unclear that we're going to get anything in terms of sound sync. But Maybe it's just because we're calling it sloppily at the moment. Maybe the fact that we're doing the lock in a bad way is causing the hiccup. I don't know. Or maybe we've got something else stupid going on. So for now, I won't despair quite yet. It was a little despairing to see it, but you know, maybe we can undespair. So what we want to do here is, since we kind of know roughly what our frame sync is going to be, in fact, we can sort of look back at the beginning here and we can see what our frame situation looks like. It's pretty consistent. We always are actually getting that 33 frames a second that we want to pretty much across the board. When our app is not getting interrupted or anything, we're getting a pretty good read on that, it seems like. So if that's always getting 33 milliseconds of frame round trip time, then basically what we should be able to do at the very least is just write 33. We should be able to sort of like keep ourselves that far ahead in the sound buffer, and that should be sufficient for our purposes. So basically, when we go to actually write the sound out, which is right here, when we actually go to write the sound out, we should be able to just do it by writing however much ahead our actual frame time is, and using that. So basically, what we want to do is we want to do something along the lines of this. So we kind of want to go here and say, all right, we're going to do our game update and render, and then we're going to go ahead and we're going to write into the location that we think the sound will be at that time. Well, yeah, there's a couple different ways we could do this. Let's think about this. This is why I said this was going to be very hairy and complicated. I think I said it originally. We may have to eat up some Q&A time on this one because it's going to be pretty hairy. All right. So the problem that we have is basically we know we have to write from the last position that we wrote to, right? Because our sound stream has to be continuous. And so basically what we're doing here is we're sort of doing exactly that. We're passing the bytes to write, and we're passing the samples here. So what we're trying to figure out here is how far ahead of the current play cursor we should be writing. So we're doing the play cursor plus whatever our latency is. Now we're expecting the play cursor, right, from wherever it was. We basically want to use the play cursor plus 33 milliseconds. We want to use the play cursor that we sampled back when we flipped the previous frame, and we want to add our frame latency into that effectively, right? So what we want to do is we want to actually go, and I guess this makes this not really debug anymore. We actually want to go ahead and do this play cursor access. We want to do that access actually back here, right? If that makes any sense. So what we want to do is say, okay, let's go ahead and take that sample at that time. We'll basically say, all right, when we actually grab this, this is no longer, no, 5-minute warning, no. Wait, this is selectable text. Is that actually true? No, I thought for a minute it was like letting me select this, which is kind of hilarious. It's actually talking about Emacs, so that's fine. Okay. Anyway, so what I got to do here, or what I'm going to do here, is I'm going to say when we do our flip, we're going to look at whatever the sound card said it was at that time. So we're already doing that. So now this is no longer debug code, basically. This is actually going to be real code. So we're going to access that play cursor and the write cursor, and we're then going to record them for debug purposes in debug build so that we can draw them. But we're actually going to always also have them as well, if that makes sense. So we're going to go ahead and say that there is a play cursor and a write cursor, drod, that's good. I'm going to get them both here. There we go. And I will actually store them, assuming that they worked. We'll have to handle it with the sound is valid thing here. Otherwise, the sound is not valid here. There we go. And then I will simply set last play cursor equal to play cursor. And so we will actually have some understanding of where the play cursor is. Now we're going to have to handle startup specially. dword play cursor. There we go. To do KC handle startup especially. But then once we get through here, and our sound is valid. Where is our sound? Sound is valid. Our sound is valid also needs to be stored here as well. Okay, so our startup's going to be totally messed up. There's no question about that, but I'm just trying to get the actual frame-to-frame update working properly first. So when I come in here, I no longer need to do this. Basically, all we need to do is ask whether the sound is valid or not, and assuming the sound is valid, then we do the computation using the play cursor that we already have. So in here, instead of using play cursor, we will use last play cursor. There will be no cursor queried here, and we'll do our computation off of that. Now, when we get that, we will then ask to write essentially however far ahead we want for our latency, and that latency can be the frame time plus some if we want to add additional buffer in there. So whatever the latency sample count actually comes out to be, let's take a look at how we're computing that right now. It looks like we're doing a 15th of a second. So maybe what we'll do here is actually shorten that down for now to actually be 1 frame's worth. So that would be basically the samples per second divided by the frame rate. Okay, game update hertz. And then if we wanted to move it back to be 2 frames worth, so it's always writing an extra frame ahead, we can do that for now by putting in the 2, right? So we can put like frames of audio latency, something like that. We can actually say that that's a thing that we have, right? So we have that. So let's take a look at that for a second here. I think that's a little more sane. Of course, it's not really going to fix any of our problems that we had, but I just wanted to get that in there first. Of course, the fact that I hear no sound right now is not a good sign. But looking at it, it does appear to be a little more stationary and stable. Maybe. I don't know about that. Is that more stable? Sure does look more stable to me. Those are not double lines. They're just, we're using stretch blitz. So remember, it's going to kind of stretch our graphics a little bit. So it looks, that's looking better to me. That is looking better, I feel like. Wouldn't you say? I don't know. It looks a little more stable to me. It's still a little variable, more variable than I'd like, but that looks more stable. So maybe, if we're very lucky, it was just the fact that we were locking the buffer kind of wonkily that was causing it to be errant. And I'm really crossing my fingers that that's what it is, and not just the fact that the sound card's going to be really inaccurate on this machine. Wouldn't surprise me because it's one of those weird Realtek embedded like 5-cent chips or whatever. But hey, the reality is that's what's in a lot of computers, so, you know, we got to work on that stuff. We can't have some kind of gourmet sound card all the time. That's not on the table. All right, so sound is valid. Let's take a look at what goes on with sound is valid. Basically, we've got sound is valid being set to true when we can get the play cursor, and sound is valid equal to false when we can't. So if that's equal to true, I'm not sure. Are we, for some reason, not, oh, yeah, that's good. We dropped that succeeded line. You gotta love that succeeded. It always comes and gets you. I think it succeeded. Let me double check again. I forgot what that actually was. So basically, that was get current position and return values. It's DSOK. So no, I guess I don't use succeeded. I use DSOK equals DSOK. There we go. So that should turn our sound back on. There we go. So at least our sound is back on now, but we're still getting scratchy, so we're still got a bug. And it looks a little gappy. I don't know. We still got a bug, though. You can hear that scratchiness. There's no real reason for it. So we're doing something stupid. I'm just not exactly sure what. So let's step through and see what's going on here, because I kind of did that a little bit hastily. It does say the Q&A begins now, but I think I'm going to go through the Q&A time a little bit just so I can kind of finish debugging at least the step that we were on, because I don't want to sort of lose the mental state, if you will, of what the changes that we were trying to make, because it's nice to be able to make a single change and then kind of like put it down and say, okay, we're basically done. So I'm going to remove this to do because that is exactly what we're doing here. So assuming the sound is valid, we're going to take a look here and look at where we were in the sound output, and we are going to map that into our sound buffer. We're going to say that, and that's just where we're going to write to, right? Then we're going to take wherever that last play cursor is, so that's wherever we flipped the last frame. We're going to take a look at where that is. We're going to advance however many samples of latency we want. We're going to advance there times the bytes per sample. And then we're going to basically say that is the location that we want. We're going to map that essentially into the buffer size as well. So we're modding both of these by the buffer size to make sure they both stay in the buffer. So assuming that the byte to lock is greater than the target cursor, that assumes that it wrapped, I guess. It's just assuming that it wrapped. Then the bytes to write is the whole size minus whatever the byte to lock is. So this looks a little hairy to me, actually. Okay, so this is... We're just going to say we're going to check that next. But I want to take a look at that. So, all right, so we'll get rid of this now because we're actually debugging that. So we make the sound buffer. We basically say how many samples we're going to write, and that's however much we computed in here. So this guy is controlling everything. This is basically compute how much sound to write and where. All right. Okay. So we have that. I would like to know where does running sample index, where does that get updated? So that gets updated in here. So basically our fill sound buffer will advance that, and it's updating it correctly. So that's good. Okay. So we're going to lock that. We're going to figure out what's going on there. We'll look at that. That's what we're going to check a little more detail later. So we call the game update and render, and that actually gets our sound output for the sample, the number of samples that we thought we wanted, which is basically however many bytes there are divided by the bytes per sample. That's how many samples we're going to write. So that's fine. And then we're going to check if the sound is valid, meaning if the last time we looked at the position, it actually was able to give it back to us. We're going to go ahead and fill the sound buffer at that point with whatever came back from the game. We're then going to sleep. We're just going to go ahead and wait and let it catch up to where that should roughly have been, and that's fine. We're then going to go ahead and do the seconds elapsed, and then once we actually do the flip, we're going to look at where the play cursor was. So that doesn't look totally stupid to me. There's nothing obviously dumb about it, but of course there's a lot of math in there, and it does seem like it's like a little finicky. One thing we could do, and maybe this is a good idea, is to sort of encapsulate some more of this math. We're doing a lot of this math by hand here, and there's a lot of possibilities for error, like when stuff is in samples versus in bytes and stuff, and it's kind of the onus is on you when you write each individual equation to do it right. So it could be that we should go ahead and encapsulate that. So we have a handle that works in samples or something like that we just used, and we know that it gets mapped down to bytes properly, something like this. We could think about that. But for now, I wanted to take a look at this. So basically, let's see what happens the first time through here. We have some target cursor, right? The first time through here, sound isn't going to be valid anyway. The next time through, we're going to have a location, and we're going to have a running sample index set to 0. So we're going to do an invalid write the first time through, which is why I said we have to handle startup specially, because we're going to write from the beginning of the buffer to where we should write. But really, what we should do is only write from like the write cursor up to there. So really, there's a thing that's like if it's the first time, it should use the write cursor. So like something like this to do if first time, let's do this. So all you actually have to do is the running sample index, the first time sound becomes valid again, basically. We would say if sound was not valid, right? If the sound was not valid, so we lost where we were playing somehow, which would be on startup, or at some other time when the buffer went haywire or some weird thing, which probably should never happen, but let's say it did, then that running sample index where we need to write should just be the write cursor, right? It should be the write cursor, like where we should write to, and we just need to map that into samples. So in order to do that, we just have to divide by the samples, the bytes per sample, right? That's really all we have to do. So we're just going to do that. And so that actually at least will make it be more correct in theory on startup, I think. We'll have to actually debug that. So I think that's right on startup now. As well. Let's go ahead and look there. Take a look at that. Special handle startup. I said there it is. Especially because now we're actually handling that. So we've got bugs, but we are actually at least trying. So, okay. What I'd like to do, I guess, is take a quick look at what actually happens when we come in here. But I want to check out this equation by inspection first, just so I can see what's wrong with it. So anyway, okay, we've got our byte to lock, right? And we've got our target cursor. So if the byte to lock is ahead of the target cursor, then that basically means, I guess, that we're wrapping. So we're kind of going to have to write all the way around the buffer, if that makes sense. So our bytes to write at that point are equal to however much we have left in the buffer, that seems right, plus however far we need to go to get to the target cursor. That seems correct. Otherwise, so in the other case, if they were equal, what would bytes to write be? Bytes to write would just be nothing, and that seems right, because if they're the same, we wouldn't need to write anything. And in the other case, where the target cursor is head of bytes to lock, we just need to go that far, right? So that does seem about right. So what I would like to do now, I guess, is just take a look at what happens the first time through. And you know what we could do as well is we could do an output debug string here to kind of give us just a look at what's going on just periodically, right? We could do a thing where we basically say, okay, let's go ahead here and just do a little, do it this way. Let's just do a write that's just basically going to tell us where we wrote to, where the play cursor was, that sort of stuff. So let's just do something like this, where we say the play cursor, whatever it was, the byte to lock, and the target cursor, and the bytes to write. So that just so we can have a little running log. Again, just a sanity check, and then the next step would be obviously to actually go ahead and draw these out a little bit better, so we can see why exactly we're getting that skipping. Because I could draw these writes in as well. So bytes to write. Let's see here. Target cursor, bytes to write, byte to lock. There we go. So now we'd also get a log of our audio, so we can just take a look at it here and kind of see what's going on. So looking at this, right, this is actually kind of roughly what we would expect from a hardware that wasn't reporting itself very granularly, right? We're basically getting a byte to write value that stays locked at some very close values. So it's either writing this much or it's writing this much. And so that's exactly what we'd expect for something that updates at a non-cycle granularity. So that seems totally reasonable. It also kind of tells us, wow, that the granularity is not particularly good if that's actually the case. And we could actually see, I guess, what the granularity was if we wanted to. One thing that we could do, which would be kind of fun, I suppose, is just to sit in a locked loop and see how often that updates. That would actually tell us, I guess, exactly once we actually start things, once we actually start the direct sound buffer playing, wherever that is. Play. There it is. We could sit in the locked loop right here and actually take a look at that. In fact, I may actually suggest that that's actually what we want to do, so we can see what our granularity is just right off the bat. So I'm going to go ahead and do that. So basically right here, I'm going to go ahead and do a while loop that basically just locks us up. The app will never exit when I put this in here. Basically what I'm going to do is I'm just going to take a look at what that play cursor and what that write cursor are reporting as we go. So basically, I'm just going to do this call right here in a locked loop that will do nothing other than it, and then I'm just going to print those out. So I'm going to print out play cursor and write cursor as bytes. So play cursor and write cursor, and that'll let us see how often they even update at all, like what the granularity is. Yes, thank you for telling me that it is unreachable code. It certainly is unreachable code. I'm well aware of that. Fine. Let's say while global running equals true. Are you happy about that? Does that make you happier? Thank you. All right. So now, oops, got to have a carriage return in there. So now we should be able to see as we go. Did I miss a carriage return in the other one too? No, I didn't have it in there. So now we should be able to see what the granularity is here of the sound cards reporting, right? This will basically tell me how often it updates. Because you can see basically it just reports the same thing over and over and over and over again. And when it does go up, it goes up by a very specific value. So if I do this calculation, right, this is in bytes, remember, this is printing out in bytes. So if I do this calculation, the sound card is giving me back that position. The previous position it gave me back was that one. And that's 1920. Well, 1920, first of all, we know we are running at 4 bytes per sample, right? That is our bytes per sample, 2 16-bit values. So I divide that by 4, and I get back 480. So 480 samples should roughly be, 480 samples is my value. I'm going to write that down here so I don't forget it. 480 samples is the granularity that I can hope to get back from this thing. And the number of samples per second is 48,000. So assuming that we're updating at 30 frames a second, that 480 should actually be 3 per frame. So it should be enough for what we're trying to do to work. That's above Nyquist, certainly. It feels like that should be able to work. I have to think about this. So it's updating on 480 sample granularity. For each frame, right, we have 30 frames a second. So we have 1,600 samples in a frame. So 3,200 samples is how many ahead we would be writing. We certainly shouldn't be getting skips from that. So we're definitely doing something wrong. I'm just not exactly sure what it is. But that's good to know. I'm just going to drop a little comment in here next to this little while loop that we just made. So basically, I'm going to put an if0 around it so it doesn't compile. But then I'm going to put a little thing in here that says, note, Casey, this tests the audio update frequency, or I should say the play cursor right cursor update frequency on the Handmade Hero machine. It was 480 samples. Right? So there you go. So 480 samples was our latency. All right, so moving back to where we were at before, we're getting our nasty audio skip. And why are we getting that? So the play cursor was here, right? Our byte to write was quite a bit ahead of that. And then the next time the play cursor was here. I guess we should also probably be recording what the right cursor was. Maybe we're not far enough ahead of it. That's a good question. I guess I'll double check that as well, because we don't know how far ahead that right cursor normally is. Well, actually, you know what? We did, because I just actually ran the thing that said that, but I'm going to add that into our thing here. So last play cursor, I'm going to put in the last right cursor as well, or actually not even the last one, get current position. I'll actually just go ahead and call that right before we do our write, and then print that out, so we can essentially see exactly where we ended up writing to. So basically what I'm going to do here, right, is I'm just going to say, okay, get that current position right in there. And this should probably, we should probably put internal builds around all of these things. Where is the build.bat here? Handmade internal. This. We're going to have to go through and put that around a bunch of stuff. But anyway, we're going to take a look at that and say, okay, give us back the play cursor and the right cursor right at this time. We're going to ignore the play cursor for now, but then I'm actually going to go ahead and do this printout down here so that what I can do is say, all right, when we filled that sound buffer, where did it actually think we were? So this was the play cursor, this was the last play cursor, and then this is what the play cursor and the right cursor are now. Right, so that we can just see, did we actually just miss our timing or something? Are we not giving it enough headroom? That sort of thing. I'm just trying to figure out what our problem is with the skipping. So I'm just trying to look at where we are writing in the buffer, if that makes sense. So let's take a quick look at that. All right, so the last play cursor was here. By the time we query it, it's here, so it has advanced once. Here is where the, yeah, so that's the numbers don't lie, ladies and gentlemen. The numbers do not lie. Basically, the right cursor is just hella ahead of that play cursor. So it looks like we're pretty much going to have to increase that audio latency. It looks like the audio latency just isn't going to be enough. That's unfortunate. That's a lot of audio latency if you think about how far ahead that is. Gosh, yeah, that's kind of crazy, but that looks like the truth. Is that really right? So what is the delta there? What is the mandatory audio latency? Basically, the lowest audio latency we could ever hope to get coming out of direct sound here. What is it? 5920. Holy cow! Look at that. Look at that value. Oh man. All right. Well, all right. That's the number of samples, right? And that's like several frames, right? So how much of a second is that? If I do the divide, paste. That's oops, I did that wrong. Let me do that one more time. I need something better than this calculator for doing this stuff. So that's the number of bytes. So divide by 4, that's the number of samples. And so basically 1440. So 1440. Wow, so it's actually, gosh. So it's actually asking for 30 frames a second ahead of latency just to begin with. So I'm going to have to be even more than that. Yikes. So I don't know. Maybe I'm misreading these numbers. Maybe it's just, like I said, it's always a bit of a rush here when I'm doing stuff on a live stream. So it's a little bit tough for me. I will say that. But that looks to me like basically what's happening is we need even more latency above what we were already specifying. I could be wrong about that. So we'll just go a little hog wild here and see if that's true. If I say 4 frames of audio latency, for example, what do I get? Well, that's scary, people. That is scary. Well, I'm glad we stuck with it because we know the piece of information now that we needed to know, which is that basically we are talking about something that's going to force us to write pretty far ahead, and we do have a very narrow range there. Maybe we should probably look at the right cursor first, look at how far ahead it is normally, and adjust our latency to compensate for that. But yeah, there's not a lot more we're going to be able to do. It looks like 2 frames of latency is just not quite enough to make it work. So we'll have to, yeah, it's just not quite enough and it catches up to us. All right, well, not what I would have hoped for. That's a lot of latency. That's a lot of latency, but that's just what we're going to have to live with for now. Yeah, that's just quite a bit that it's basically mandating there. I guess that'll be an interesting thing when it comes time to kind of tighten things up for ship. Maybe we implement X audio and we see if we get lower latency out of it, or we hope that we do anyway. I don't know. But I would say that's about probably it for now. We're almost out of time. I would like to take 10 minutes of questions if we can, so I don't want to go any longer, certainly. But we would probably have to still tighten this up a little bit tomorrow because I kind of slammed all that in here and there's a bunch of loose ends, like all these printouts and stuff, so we're going to have to wrap all that stuff up as well. So we're not really done with what we wanted to do today. We're pretty darn close, though, but we're not quite done because what I want to do here is actually draw where we're writing to so that we can look a little bit more at what's going on. So I'm going to say draw where we're writing our sound, because that's where I'd hope to get to. I'd hope to get it to playing smoothly and drawing it out so we can see. And so we'll have to do that tomorrow, which means we might spill over into Monday, or maybe we sneak in a secret weekend stream. You know, you can work overtime once in a while. So we'll see. All right, so with that stated, let's actually still do 10 minutes of questions. If you could please make sure that your question includes C Muratori in it somewhere so that I will... is your audio pointer code calculating independently of the variable fixed visual frames per second? Yes, essentially it is. So basically, I have those two decoupled at the moment. Basically what's happening is the audio is just looking... So the reason that I have to do that is because the audio's clock is not guaranteed to synchronize with the computer's clock, right? There's no reason why the audio output clock has to actually match the wall clock. They could diverge, and if they diverge even by a little bit, then over time that could lead to a big error that would cause our audio to be writing to the wrong place, right? So what I need to do is I manage my own frame rate here, right? I manage my own video frame rate. And then what I do is I just look at where the sound output is when we flip. And I go, okay, that's where we were when we flipped. So ideally, we want to write to a particular frame boundary. We need to look n frames in the future and write to where a frame boundary will be in the future. That is the earliest frame boundary we could write to, right? That is past the latency of, that is past the audio latency of the sound card. Now we could go a little further of this and write just only however much the audio latency of the sound card was and not truncate to a frame boundary, but that would basically pass that burden onto the game code to have to think about its audio output being uncentered from a frame. Should we do that? Should we not do that? I don't know. I mean, I think you kind of want to optimize more for the well-working hardware case where stuff goes out the HDMI kind of more synchronized, and maybe, you know, penalize the OS in some sense for being crappy about that sync. So I don't know. I'm disinclined to complicate the game code in the service of this. But, you know, it's, again, it all depends on what your aim is. If you want to get that extra, you know, millisecond or two of latency out, because you're an audio game, like, for example, a beat matching game, you make different trade-offs. And so I'm certainly not going to say that one way is right or one way is wrong, because that's totally not true. But I think for this game, I'd say let's keep it on frame boundaries, and that's that. What sort of problems can high audio latency introduce? Well, they don't really introduce problems per se. They just make the experience feel a little less tight. Ideally, I'd like 1 frame of audio latency so that basically the visuals are almost exactly in sync with the audio. Perfect in best of all possible worlds, they're exactly synced, right? But that's not, I guess, realistic in this particular case. Now, if we wanted to, we could trade visual latency for audio latency, right? The way that we do that is we'd render frames and save them. We'd buffer them up, right? So we'd render like 3 frames, and we'd wait to flip the first frame until we knew the audio had caught up, right? And so we'd always sort of be flipping behind where we knew the audio was. But that would introduce control lag into the video, and that seems like a really bad trade-off. So we don't want to do that, right? So we're kind of at a situation where we don't have any choice but to take the audio lag, because that's just what's going to happen. And what that means is that, you push the button, and ideally, if you shoot or something, you want the shot sound to happen exactly as you push the button. And audio latency, the higher the audio latency, the more lag there is between when you push that button and when you hear the result. Now, people are actually very forgiving about this sort of thing. They sort of interpret things as happening. They interpret sounds as happening synchronized to events, even if they aren't. So if they see a shot and they hear a shot sound, even if they're very far apart, people actually think they're happening at the same time. So as long as your game doesn't rely on them hearing the sound and reacting immediately to it, like a beat matching game does, you're probably actually okay. But even though the brain accounts for it, I still do feel, and this is subjective certainly, but I still do feel that narrowing that audio latency does make it feel nicer to play. Like taking some of that slop out, it feels more visceral when your brain is doing less of that correlation. You kind of are sort of aware of it when it gets above a certain threshold. Now, where is that threshold? That threshold may be at like 100 milliseconds for a lot of people, right? Which we are well within. But if that's at 30 milliseconds for most people, let's say, then we are not even close. We are going to sound a little laggy to them. And so that's why it's just disappointing. I was hoping that the hardware, Windows to hardware pipeline would have been better there. It isn't. How do you find the low-level sound libraries to work with? You choose direct sound. How did you make a meaningful choice of that over X audio or something else? The reason is because it's the only thing that's supported by default besides Waveout on XP, as far as I know. I can look and see whether there's another one that's supported by default on XP. But I wanted something, again, XP was our compatibility target. We ran on it already and everything worked just fine. And I wanted to make sure that that continued to be the case. So I'm disinclined to switch to something else, at least for the prototype layer. What we will do perhaps in future ones is we will check to see if X audio is there and try it. Now, I think one thing that I would point out is I suspect it would not surprise me in the least to find that the latency is no better with X audio. So I know a lot of people are always excited about like, oh yeah, if the latency is just bad because you're using direct sound, but they don't actually know because they probably have never tested it on this particular card or whatever. And so a lot of times people get excited about something like you should be using this API or you should be using that API, but that doesn't actually come from experience and they're just kind of speculating, right? And so what I would emphasize here is we don't actually even know if that will improve things. We will test later whether that will improve our audio latency. But it's entirely possible that this machine's audio latency of just is what that is, and we're not going to get any better. So we'll have to actually see in practice if that's the case. So I wouldn't get too excited about X audio or WDM or any of the other technologies because it may be that they're all roughly the same latency, and it's the sound chip that is actually causing the latency and its driver is just latent, right? And that could very well be the case. So I would hold off on that kind of speculation until we actually have some data, because otherwise it's just pure guesswork, suggesting that some or another API will be better. Let's see. Let's see here. The sound is looped. Begin loop is... Direct sound docs say don't write before right cursor. Why are we safe ignoring it? Suggestion, don't overlap play and right vertical lines. Use half screen for each. That is a good suggestion, by the way. Well, we're not really probably going to ignore the right cursor. Like I said, we will probably use it in the future. But what you have to understand is the right cursor actually isn't relevant to us. The right cursor is just something that says don't write before this. Now, what we actually care about is where the play cursor is, right? And since the play cursor and the right cursor are actually technically usually locked, but they're not really, it's under no obligation to lock them. So what we want to do is look at the play cursor and say, ideally what we want to do is write this far in front of the play cursor, right? So all we really want to do with the right cursor is just add a little bit of code that says, make sure if for some reason the right cursor is actually further out than that, on average. Like we'll look at where the right cursor, how far apart the right cursor and play cursor are. On average, however far the right cursor is away, if that is more than what our expected latency writing is, then change our expected latency writing to encapsulate that. But we don't actually want to use the right cursor because the right cursor is actually irrelevant. It's just something that says your latency better be more than this. But it doesn't actually help us, it doesn't actually give us information about where the sound is playing, which is what we actually care about for synchronization, if that makes sense. If we use the play cursor as offset, could we not overwrite previously written audio data? Well, again, maybe I need to draw a diagram because this seems to be confusing people. So I'm just going to go ahead and draw it one more time, just so we can kind of get a feel for it here. I don't know what I'm going to use to draw it. I guess I could use smooth draw again, but I think I'm just going to go for the good old Microsoft Paint, painting tool of champions. So anyway, just to be 100% clear about what's happening here, we're going to get something, let's do our frame ticks again. So here's our frame ticks. These are happening at 30 frames a second, right? So basically each one of these is going to be 33 milliseconds approximately, right? 33.333 bar. So what happens is we're going to query direct sound, and it's going to give us back something that looks like this. It's going to give us back something that says the play cursor is here and the right cursor is here, right? And we now know that the difference between these actually itself is like 33 milliseconds, if I remember correctly, right? That's what we computed. So given that this is true, right? Excuse me. What we want to know is we want to know wherever the play cursor is, right? We want to know where we can safely write to. That's a frame. You know, what frame boundary we can start writing our audio to. Where is that in our, how should I explain this? Which of these frame boundaries can we safely write to such that the right cursor, if you will, won't catch up to there by the time we actually output it. And we want it to be as close as possible to the fact that when we actually do the page flip, the play cursor will hit that when we do the page flip. Now, what we basically determined is that that's impossible because our frame rate is actually roughly the same as our audio latency. So we're basically in a really bad position where we can't, it would just be cutting it too close to try and do it. So we actually need 3 frames of latency to make this work. And the reason for that is that since this is about 1 frame ahead, right? The right cursor is about 1 frame ahead when we did our testing. What that means is that wherever the play cursor is, we know we probably can't write, we know we definitely can't write to this because it's already behind the play cursor. And we know that we probably can't write to this because given the granularity of how this is being updated, we don't even know exactly, the right cursor could be anywhere really in practice. We're in a lot of trouble. We don't actually know what's going on with a lot of these things because they're moving as we go. So really we have to target basically 1 frame ahead of the next frame that it could be. And that's where the 3 comes from. So we're on this frame, right? We have to skip this one. We have to skip this one probably, unless we hit it dead on. And so we gotta always write to this one. And that's where we come up with our computation. So the answer is, can we ignore the right cursor? No. We have to look at that delta there and find out what it is and make sure that whatever our frame latency is, it's above that value, right? But we don't actually care where the right cursor is, ever. It doesn't matter. What we care is how far it is from the play cursor. We care about this delta, right? Because we're trying to synchronize with this. We're not trying to synchronize with this. We don't care when the right cursor hits something. We care when the play cursor hits something, and that's about it. So really, it seems like this is stupid when I'm saying it, and that's because this audio card is so latent. But imagine what would happen if this audio card was better. Imagine what would happen if when we queried it, it looked more like this, right? So here's the difference, right? So here's the play cursor, here's the right cursor. And now you're saying, well, let's synchronize using that. Well, that's stupid, because what's going to happen is now you've just introduced that much audio latency on your frame boundary, because you're going to synchronize with when this thing hits that thing, and that's wrong, because this is actually the playback. So on a good card, you would be very much better off syncing with the play cursor, because it's going to be very low latency, and that is the thing you're trying to sync with. So you're only checking this delta here to figure out what your safety margin is. On a bad card, well, it's already totally latent anyway. So I actually don't mind the fact that we're a little more latent. Like, let's say we're an extra 10 milliseconds latent when the thing was already 33 milliseconds latent isn't as big of a deal to me necessarily. Like I said, we could be a little more proactive about that and cut that down so that we wouldn't have that by allowing the game to write on non-frame boundaries. But I don't know. I just don't know if I feel like that's a good trade-off to make there. We'll have to see. So that's currently what I'm thinking. It looks like it might be the case that just like you'd favor direct sound over waveout in Windows XP, you should favor Wasapi or waveout for Vista 7. So we might need two backends for Windows based on OS if we want to support both. Yes, and that's why I said what we'll probably do is we'll test at some point Xaudio, or we'll test whatever the very latest thing was on Windows 7. We'll see if the audio latency is any better. If it isn't, then we'll be like, okay, this is just a waste of time. But if it is, then we'll just have a thing that says, if we were able to open Xaudio, we'll use it. If it wasn't, we won't. Would rendering at 60 frames a second instead of 30 frames per second help with this latency problem? Not really. It does cut down the extra frame latency by a little bit. So the total latency would go from an extra 33 milliseconds to an extra 16 milliseconds, potentially on the rounding. So whichever direction it rounds, you're rounding to a different granularity, so it helps a little bit. But that's only because I said that I wanted to keep it frame synchronized for audio. If we decided to desynchronize it and allow the app to basically be writing to some non-frame centered location, which might be a better decision, you know, as I'm saying it more and more, I'm thinking maybe we should just allow that because it doesn't really matter. The game doesn't really have to know. The game could think it was frame synchronized, and really all it's doing is cutting down that latency a little bit. So it's probably a better thing to do anyway, but at the moment we're not actually doing that. But yeah, so if we switch to that, then it wouldn't change at all. The frame rate would be irrelevant. Could you change latency latency values based on detecting the sound card settings? Yes, and that is what we will do based on the right cursor. So tomorrow we'll take a look at that right cursor, and the right cursor will determine our sound granularity basically. Is it possible that OBS is affecting the audio latency? That's a very good point. Yes, it is very, very possible. I had not thought of that, but you're totally right. It could be that the fact that I'm broadcasting this is what's causing that. That could very well be. I had not thought of that. It's a very good point. We'll have to run this after the stream's over. I'll have to run it and see to see if it's different. Let's see here. That said, let us go and get started here. Someone on the chat was mentioning that we had an off by one error. Now we probably have a couple bugs in what we